Hey guys, as always, we are going to do some examples today so that you are not left all alone trying to do your assignment by yourself. So today's lesson was all about polarity. We're starting to talk about IMF, so intermolecular and intramolecular forces, to wrap up this unit. And today we are doing work with polar and nonpolar molecules. So what we're going to be doing today is taking a look at some compounds. So we have our compound formulas here in our left-hand side of our chart. And we're going to be using this chart, this is called a Pauling table, to help us determine whether or not the bonds that are formed between these molecules or these compounds are going to be nonpolar covalent, polar covalent, or if they're an ionic bond. Now, we should be able to tell just from looking at the formula whether or not the bonds are going to be ionic or covalent, because you guys know by now that ionic bonds form between a metal and a nonmetal. And then we know our covalent bonds form between two nonmetals. So just from looking at the formula at this point in time, we are able to do that. However, we're going to use the electronegativities today to help us determine the difference between the nonpolar and the polar covalent. So we should have watched our lesson video for today, but in case you didn't, for whatever reason, remember that nonpolar covalent bonds have an equal sharing of electrons, so there's not a partial charge on either of the elements. And then in a polar covalent bond, there is a partial charge. So one of the elements in the bond has a stronger charge to attract that electron, which sets up that dipole. So in order to determine the difference between the nonpolar and the polar covalent, like I said, we're going to use this Pauling table. So on this Pauling table, we have these different numbers, and these numbers indicate the electronegativity of the element. Remember, electronegativity is just the ability of that element to attract a shared electron. So of course, it makes sense that as we go from left to right across the table, those electronegativities are increasing, because remember, our nonmetals over here on the right-hand side, they are looking to fill their octet rule, and they're looking to gain electrons. So they have an affinity for taking those electrons. So of course, their electronegativities are going to be higher than our metals that are looking to get rid of them, that are looking to donate them. So our electronegativities are increasing from left to right. So now let's take a look at what we are going to do and how we use this table. So good for us, we have our electronegativity range here, and what we're going to do is we're just going to do some simple math to determine the overall difference in electronegativities that will then determine our bond type. So the first thing we have to do when we're doing these examples is determine the electronegativity of both of the elements in the formula. So here we have sodium and we have chlorine. So we know this is sodium chloride. So let's go up here and find sodium. So the electronegativity value of sodium is 0.9. And then the electronegativity value of chlorine is 3.0. Now again, the element on the right-hand side is going to be the element with the strongest electronegativity. So of course, we will put him first in the formula. So we're not going to be dealing with negative electronegativities. Everything will be a positive number. So we're going to put our highest value first, and then we will subtract our lower value. So chlorine is 3.0 and sodium is 0.9. So to show our work, we're just going to do 3.0 minus, and it was 0.9 for sodium, equals, and then of course you guys have calculators on your phone. I'll pull up my calculator from my computer really quick. So we just do 3.0 minus 0.9, and that gives us 2.1. So an electronegativity difference of 2.1. Now with this value, I can tell whether this bond is going to be nonpolar covalent, polar covalent, or ionic. So 2.1, let's go back up here to our type of bond. 2.1 is larger than 1.7, right? So this is going to be an ionic bond. So you can either type it all out, or you can just write the abbreviations that I have there for you, which is IB for ionic bond. That makes sense, right? Because we know that an ionic bond is a bond between a metal and a nonmetal. So here's sodium, which is a metal, chlorine is our nonmetal, so it would make sense that this is an ionic bond. So the way you read this chart, if this value right here is less than 0.5, it's nonpolar covalent. Okay, that means those electrons are being equally shared. Remember, that's going to be a symmetrical molecule. If this value, so the electronegativity difference, falls between 0.5 and 1.7, it's going to be polar covalent. So there's going to be an unequal sharing of that electron, and we're going to have an asymmetrical molecule, like water. And then if our value here, our electronegativity difference, is greater than 1.7, that's going to be an indication that it's ionic and you're not even sharing those electrons, because remember, in an ionic bond, you're transferring the electrons. So that makes sense, okay? So it's pretty simple. You do that all the way down. The other example I just wanted to do really quickly was for CH4. So here we have multiple hydrogens, like in sodium chloride, there's only one sodium, one chlorine. Hydrogen bromide, same thing, one hydrogen, one bromine. Here we're running into where we have 4 hydrogen. You don't have to multiply the electronegativities. You just have to take the electronegativity of 1 hydrogen. So don't worry about there being 4 there, just treat it like you normally would. So carbon is 2.5 and hydrogen is 2.1. Because there's 4 hydrogen, you don't have to multiply this by 4. You don't have to. Don't worry about that. You just leave it as it is. So carbon is the higher electronegativity, which is 2.5. So we'll do 2.5 minus 2.1. And that just equals 0.4. 0.4 is less than 0.5, so this is going to be a nonpolar covalent. Or if you don't have time to type it all out, again, you can use those abbreviations I have here for you. All right, so those are your 2 examples. Pretty straightforward. I would imagine this should not take you more than 10 to 15 minutes to complete. But if you have any questions, of course, let me know, and I can go through more of these examples with you one-on-one.